So yesterday I shared a performance experiment in which I started caching cryptographically signed URLs in Redis. And after I posted that, it occurred to me that I don't think I've ever talked about my strategies for generating cache-friendly or CDN-friendly signed URLs. And the way my strategy works is by bucketing the expiration date of a signed URL. So I might bucket based on month, which means that any signed URL for a particular resource that's generated within a given month uses a consistent expiration date such that the generated signed URL is the same within a month for a particular resource. So for example, given a date here, which will default to the current timestamp, in order to generate an expiration date for a signed URL, I would create a date that is the first of the current month, right? So it's August 21st right now, so this would become August 1st, and then I roll forward 1 month to get the expiration date. So the expiration date for a URL generated on August 21st would become September 1st, right? It's the first day of the following month. And to look at how this works, we can create a simple loop here where I start on August 1st and I'm going to loop 50 days, right? And for each iteration of that loop, I'm just going to add a date to that first date. And then I'm going to get the monthly bucket for the particular date and I'm going to output it. And if we run this code, what we can see here is that on August 1st, we start generating expiration dates for September 1st, so it's the end of that rolling month. And then any expiration date generated during the month of August always results in a September 1st expiration, right? Including up to August 31st, which also has a September 1st expiration. And then the second we roll into September, you can see that our expiration dates roll forward another month to October 1st. Now, from an in-application experience, this is totally fine. We'll get to the end of this bucket, and then subsequent URLs will start generating new signed URLs using the following month's expiration. Now, again, from an in-application standpoint, this is great because an application experience has the luxury of making subsequent requests to the application and generating new URLs that then get rendered within the application. But the problem is, not all signed URLs are consumed directly within the application. Oftentimes, we will use a signed URL in an external context like an email. So using this strategy, let's say I send out an email on August 31st. It has an embedded image that has an expiration date of September 1st. Now the next day the user comes in, opens that email, and suddenly that URL that was generated just maybe hours before is no longer valid by the time the user opens that email and they're presented with a broken image. So to make the signed URLs a little bit more flexible, what I tend to do is use a sort of rolling window for my bucket. So instead of using just a simple month, what I do is I check the current date, and if, in the context of a month here, if the current date is in the latter half of the bucket, meaning it's after the 15th of the month, then what I do is I take that expiration date and I roll it forward 1 additional month, which means that an expiration date generated on August 31st won't expire on September 1st, it will expire on October 1st. Right? So now if we run this code again, what we can see here is that again, URLs generated on August 1st expire on September 1st. But if we look down on the 16th here, the 15th and the 16th, what we can see is that on the 15th, the expiration date is still the 1st of September. But on the 16th, you can see we've rolled forward an additional month to October, which means that any URL, any signed URL that is generated now within the application is guaranteed to work for at least half of the bucket duration, half of the window. So going back to the example before, if I send out an email on August 31st that contains an embedded signed URL for an image, the user has more than has a month to open that email before the embedded image becomes invalid, right? The signed URL for that embedded image becomes invalid. So if we look at this, there's no point in time in which the signed URL is valid for less than half the bucket, right? If we go up to the 15th here, right, here's where we sort of hit that half a bucket, right? This is valid now for the latter half of the bucket, but then the second we get into the latter half of August, we can see that again, we roll forward that additional month. So from an application standpoint, little has changed from an experience, right? Once we get to the end of a bucket, we start generating signed URLs. That becomes a cache miss, but then quickly becomes a cache hit on subsequent requests. The benefit here is that from an extra application standpoint, right, if we're consuming a signed URL outside of the application in something like an email, we never run into a situation where a URL generated 1 minute could theoretically become invalid in the next minute. And that gives the external consumption some more buffer room, some more wiggle room. It provides a better user experience where we're less likely to create invalid URLs within a time period that should be available to a given user. It's definitely not the only way to do this. And of course, when you're generating a signed URL, you're typically, by definition, providing access to a resource that would otherwise be inaccessible. So when dealing with expiration dates, you have to consider the type of application, the type of resource, the security constraints, and so on and so forth. But typically, for a signed URL that is being fronted by a cache, like a content delivery network, we have to strike a balance between security and performance. And when we do that, I find that using this sort of rolling window of bucketed expiration dates to provide that nice middle ground between secure URLs, but URLs that are also cache friendly and user friendly and performance friendly.